So next class we have our lab exam. This is the last thing to go on your quarter grade. Everything else will go on the next quarter. You took notes on 2 different lectures, one on how to go from schematic to circuit, building the real thing, and another one on soldering and all the stuff associated with soldering. So you should have those notes out. You might want to, underline, highlight stuff, whatever. I'm going to be reading directly off of the lab exam. And of course, you can watch this later on the podcast. So just call it out if you think you know the answer. I'm not necessarily going to read through it in the same order, though. Okay, when we make our circuit board, we're left with those little copper lines. Those lines that make connections are referred to as traces. There's somebody that knows. If we were to use an IC, we may damage it easily, so we have a way of removing it and putting a new one in without having to desolder the whole thing. We put in what's called an IC what? Socket. The IC socket allows for easy removal of the IC. What is the substance inside solder that helps it flow easily? Rosin. What do we call it when we remove the unwanted copper from our board? We're making a circuit board and we get rid of the stuff we don't want, so we're left with the little lines and the little round things. What's that? Etching. You got it. Etching. Okay. What is the name of that substance that we use to etch? Okay. That's the kind of stuff we call the substance etchant, E-T-C-H-A-N-T. And the chemical, the acid that's found in etchant is often hydrochloric acid. How do we abbreviate that? HCl. Okay. Not HCI. I know it looks like an I when it's written like that, but it's HCl. The little wires that come off of an IC are referred to as the blank or blank. Legs or pins. Legs or pins are the little wires. In fact, you go back far enough, in the 20s, they referred to a woman's legs as her pins. That was the kind of the slang of the day. The nice pins, they would say, nice legs. This absorbs unwanted solder. We make a mistake, we get too much solder on there, we put the stuff down, it's called desoldering wick or braid. Remember, it's the copper stuff that we stretch and we put on top. Desoldering wick or braid. Let's see. What is this part called that has little tiny miniature parts inside? IC. And as you may recall, an IC, how can you tell what an IC does? The numbers. You check up the numbers in a book, and then that will tell you what it does. Inside are little miniature parts that have literally been etched, carved out of silicon. Okay? Kind of like we etch the circuit board, we can etch silicon to make the little miniature parts. What substance is an alloy of tin and lead? Solder. You got it. What do we call it when you coat the end of your soldering iron with a little bit of solder? Tinning, because it's tin in the solder. That's where that came from. Sometimes you do that with a wire too, like stereo speakers often have wires that have little strands, and you twist all those strands together, and they may get untwisted and may touch one another, so you can coat those wires with a little bit of solder. That's called tinning as well. Keeps them from shorting out. Circular shape applied to the board. It's what we call the round thing that the wire goes through. Donut. All right? What's a component that stores a charge? Capacitor. What do we call those little things? They come on that sheet and we rub them down to protect the board. They're called etch, resist, blank. Transfers. Like the rub-on tattoos, the etch, resist transfers. You rub them down. You transfer them from the sheet to the board. What is the name of the board before we do anything to it? It's just covered in copper. No? That's the before, the copper-clad board. Good. After we get rid of the unwanted copper, it then becomes the circuit board. So we have a copper-clad board is the before. The after is the circuit board. What is the substance inside solder that helps it flow? rosin. I think I said that one already. All right, I think that's that section. Now the next part, you need to be able to recognize parts by sight. I'm going to be passing these around in a little bit so you can look at these boards as examples. You may see very similar boards to this on Monday. They'll be underneath trays, and you'll lift the cover up and you'll look underneath and you'll identify the parts. There'll be a pin stuck into them or next to them. Now there are some clues. By looking directly on the board, what clues do you have that tell you what the parts are? D would be what? Could be diode. Okay. Some of the letters would be needed twice, so we use another letter. For instance, T is used for transformer, not for transistor. We use a Q. So once you become familiar with those, you can just look at the board and know what it is by that number alone or letter alone. So I'm going to be passing these around a little bit later down different rows, but swap them around and get a chance to look at as many of these as possible because these are the kinds of circuits you're going to see. Now as you look at your own board there, tell me, how many LEDs do you have? How many diodes do you have? How many resistors do you have? Fixed resistors. 9. How many variable resistors do you have? Huh? 1. How many transistors do you have? 4. How many ICs? 2. Remember, one of those ICs looks just like a transistor. It's the voltage regulator right below your regular IC, regular looking IC. Okay? Let's just try a few up here by sight. See if you can identify these. Stores a charge. Capacitor. What kind of capacitor is that? Electrolytic. Very good. Means it has an electrolyte inside, just like a battery. Jeff, good job. Next one here. Good to go. An electronic switch or amplifier. Transistor. Has that little half moon shape and 3 wires that come off. Permits current to flow only one way. Diode. Now you may see a diode like that on one of these boards that's 3 times as big as the ones you had. But look at how it's got the one band, tells you which way to put it in. Unlike these that have multiple bands, restricts the flow of current. Resistor. This is a variable resistor. What's the name for a variable resistor? Potentiometer or pot, like the little white one you have. This contains many tiny parts. Integrated circuit. This is a semiconductor light. Good. This changes AC voltages. No, it doesn't change from AC to DC. It changes the voltage. It can step it up, step it down. Transformer. So you have 2 coils of wire next to each other. Usually they're not open like that where you can see it. Usually they look more like the ones I showed you when we did the lecture on them. Okay, so those are some examples. There'll be more than that, but those are the types of things that you might see on the test. All right, last section here. A blueprint or recipe of a circuit is called a recipe is the schematic. It describes all the necessary parts and how they are to be connected. This must be changed to a drawing of the actual final product called the board layout. All this was done for you. Once the pattern has been applied to the board, it is then etched. When the board is first placed into the etching solution, it changes color to a dark red. Good. The copper will dissolve where first? Remember, it starts at the edge of the board. So if we're etching this circuit board, it's going to start eating away at the copper from the edges first and work its way to the center. When the copper's gone in the center, then you take it out of the etchant. Okay, and you scrub off all those little transfers that protected the copper. Scrub them off with what? Steel wool. What's the next step? So now you got all your connections there. What's your next step? It's one that was already done for you guys. Before we could ever install the parts, what had to be done to that board? You had to drill the holes. So you get a little drill and you drill a hole for every single wire. Fortunately, that's usually done by machine. but you can do that yourself. After you drill the holes, you put in the parts. Some parts are very vulnerable to the soldering, such as the IC. The IC is easily damaged by heat or what? Static. Will a resistor work if installed backwards?
No. Yes.
Remember, a resistor is just a speed bump. It doesn't matter if you go over the speed bump this way or that way. It won't affect whether or not it works. Now, it does matter if you put in the right resistor in the right place. The colored bands tell you that, remember? You got to look at the colored bands to know which way to put, or which value resistor. But I had you put it in a certain way, and I told you it wasn't going to matter if you flipped it around, that I had you put it in that way so I could easily identify the right resistor. What about an LED? Will it work if you put it in backwards? No. What about a transistor? No. What about a diode? No. All of those things matter. A diode is like a one-way gate. If you go through it the wrong way, you're going to damage your tires, so to speak. All right. The blank on the IC tells you which way to put it in. The notch or the divot, but yeah, usually we look for a notch. If the IC has a notch, like this one right here, has a little notch, so I know which way to put it in. What tells you which one's pin number 1? The little dimple or divot, it's called, D-I-V-O-T. So we look for that next to one of the pins, like this one has a little divot right here. That tells me that's pin number 1. So if this is, let's say, a 16-pin IC, pin number 1's down here in the bottom left-hand corner. What's the pin that's directly across from it? 16. First thing you want to do when you go to solder is clean the tip of the iron and then apply what to the tip? A little bit of solder. What do we call that? Tinning. You want to hold it like you would hold a? Pencil. At what angle? 45. You want to heat up the entire blank. The donut and the wire, where they come together, what is that called? The solder joint, just like elbow joint. You want to heat up the entire joint. Where the wire and the donut come together, that's referred to as the joint. You want to heat up the entire thing. Be careful not to apply solder directly to the iron, the soldering iron, because it'll always go to that and you just end up getting a big glob on the iron you have to shake off anyway. If the joint is disturbed and does not cool properly, a dull or cold solder joint will be made. I showed you 3 examples of solder joints up on the board. One with a glob on one side, one with a glob on the other side, or both sides, and one that looked like a nice smooth mound. Which one's the correct one? Nice smooth mound. Okay? Any questions for the test? All right.